Hello everyone, my name's Adrian.
I'm Nick.
And welcome to another episode of Connect. Today we're bringing in Olivier Monnier to talk about new products being added to the SimpleLink platform. So welcome to the show.
Glad to be here. Thank you.
Yeah, so as promised last week, we're going to talk about the newest product that's added to the SimpleLink platform. We brought in Olivier to talk about it. It's the SimpleLink Multi-band CC1352P device. Now, Olivier, can you just start out and tell us why we should care about this device? What's cool about it?
So the great news is that, first of all, it's an extension of the SimpleLink platform, so we give more choice to our customers. As you said, it's multi-band, so we have sub-gigahertz and 2.4 gigahertz on one device. And the big news is that we are adding a power amplifier inside. So it's a three solution into one. Sub-gigahertz, 2.4 gigahertz, plus power amplifier into one single device.
Now, what exactly do you gain from adding the power amplifier? I'm familiar with the older devices, the multi-band no power amplifier.
Yeah.
What would a user of the device gain with the power amplifier?
Yeah. So if you look at our developers, what they are telling us, if you take, for example, a typical smart sensor network, you have the sensor, battery operated, it could be temperature, position, talking to the gateway. But just like in a building like that, sometimes they face challenges of reaching the nodes. You can have a wall, you can have a big building. So really, developers are asking for longer reach, longer distance, and that's the key point. So power amplifier is basically giving you more range to reach your sensors.
Awesome. And can you help, I guess, quantify what that improvement in range can be with the integrated PA?
Absolutely. So on the 1352P, first of all, the power amplifier, you can use it both for sub-gigahertz and 2.4 gigahertz.
Okay.
When you use it for the sub-gigahertz, you are moving from 14 dBm, 1.4, to 20 dBm. So it's a 6 dBm gain, which basically translates in a 2 times longer range, so twice the range. And then on the 2.4 gigahertz, we are moving from 5 dBm to 20 dBm. So here it's a time 4 increments.
Wow.
So on the 1352P, you can double your distance on sub-gigahertz and quadruple your distance on 2.4 gigahertz.
Wow. Okay, and so now from my limited RF knowledge, I know that there's not necessarily free lunch. So when we have these higher output powers, it's usually at a large expense to power. Can you tell me a little about the power performance of this?
You're right, and this has been the way so far, but really here we are changing the game. Today, if you want to do a 2.4 gigahertz or a sub-gigahertz plus a power amplifier, whether you use an existing solution today with integrated PA or an external PA, typically you talk about a power budget in the range of hundreds, 120, 130 milliamp. The power number for the SimpleLink CC1352P is in the range of 70 to 75 milliamp.
Wow.
So the big news is that we increase the range, but we also decrease the power consumption by 40 to 50% in some cases compared to existing solutions.
Wow. And I guess there's also some maybe BOM improvements as well. I guess you're able to minimize the bill of materials that developers have to design around.
Yeah, absolutely. So if you think about it, if you want to build your board with a PA, well, you need to have two devices, right? You need to have your, let's say, your Zigbee device plus a range extender or this power amplifier. That's two devices to purchase, two devices to maintain, logistics. So a lot of BOM size, BOM cost, but also a lot of maintenance and hidden maintenance costs. So this is a problem for designers up to the purchaser, right? And the logistic person that makes sure that you need to move to production. So when you integrate all those functions into one, you simplify design, hardware design, software design, and this overall topic around the BOM management and even moving to production. Think about quality, supply, it's a big news, yeah.
Wow. So can you take us through what kind of applications and products that you would see this product going into?
Yeah. So maybe we can take one big example is the electronic door lock. And in particular in China, for example, the rental apartment business is very big. And everyone has a phone, so the first step you want to do is to open the door with your phone. So how do you do that? Bluetooth, right? BLE is everywhere, everyone has a phone, so you need BLE. And then this door lock will need to communicate to a central hub or a gateway that will manage inside a building, maybe hundreds of apartments. So for that, maybe you need a bit longer distance. Maybe you could use sub-gigahertz. Okay. So here you have a system where you have the need for Bluetooth, BLE, and you need to have sub-gigahertz. But maybe, as I described initially, maybe you need to increase your range. You need to make sure that you really want to open your door, right? So in this case, you might want to integrate a power amplifier. So that's an existing system where we have two networks. We are addressing that, 2.4 gigahertz and sub-gigahertz. And we can decide maybe to extend the range of the sub-gigahertz. So that's a typical case that we see happening right now as we speak. And this is under the umbrella of building automation. So,
okay. And the integrated PA, I guess that's a physical improvement that all of our stacks are able to take advantage of. So whether you're doing Bluetooth or a sub-gigahertz protocol or Zigbee, they'll be able to benefit from this range extension. Yeah,
absolutely. So the power amplifier can be used for the sub-gigahertz. So maybe you have your proprietary software, or maybe you are using the TI 15.4 stack, and you want to multiply by 2 your range, so you can definitely use this PA. Or maybe you say, you know what, maybe I'm a Zigbee customer, and I really want to reach this hidden corner sensors that is difficult to reach and maintain. And in this case, I want to really increase my range on the 2.4 gigahertz. We have developers who told us that if they cannot reach a sensor, maybe the sensor will start to communicate much more often, and therefore the battery will be drained much quicker. And it costs roughly $90 an hour just to maintain a sensor node. So what we are bringing on the table is really to be able to reach this sensor all the time with low power, extending the range and the battery lifetime. It's a huge infrastructure, BOM saver, and overall project cost saving. Yes.
That's great. And I'm sure many people watching will want to get their hands on this and get started. So is this on the web? Are there tools for people to get started?
Yeah, so as we said at the beginning, extension of the SimpleLink platform. So I guess what we have here is now famous, I hope, LaunchPad from the SimpleLink wireless MCU platform. It comes with a debugger integrated, I/O extender where you can access all the different pins from the device, and I'm sure developer will want to test, the power outputs and really see by themselves how far they can go. Come with a device and download all the software from SimpleLink Academy, and off you go. Project Zero. You can enter this new world where we integrate, low power and power amplifier onto one device. And maybe you were already a developer for Bluetooth. Just continue to use the software, but now experience this new world of longer range plus lower power. That's really the key point. So LaunchPad available on the web. You can go and buy it on the TI store, download the software, and see for yourself, what kind of range can you achieve. So.
Well, that's great. Thank you for joining us, Olivier. This is a very cool new product. Thanks for giving us an intro on it. I think we both learned a lot. Thank you guys for watching and joining this episode of Connect. Don't forget, if you have feedback or topics that you'd like to see us address, tweet at us at Sensor2Cloud with any feedback. Don't forget to tune in next week. We're actually going to have a Zigbee demo that shows Zigbee network going from sensors to the cloud. It's a very cool demo. Thanks, guys.